No, we didn't have time to go over the domains and ranges of all the basic functions. As I said in class, I strongly recommend that you do that. Okay? Because those are functions that are at least should be very familiar to you since we did those functions last week. And some people are a little more familiar than others, as indicated by the quizzes, but you have to get really good with those functions because they're the basis for the whole course. Okay. The domain and range of f of x equals 1 over x minus 5. And I say unrestricted, meaning that we can try any x value we want, but if there are x values that aren't going to work for this function, then we have to eliminate them. Okay? So, question. Is there any number that isn't in the domain? Is there any x value for which you can't evaluate 1 over x minus 5? Now, somebody, I heard 0. Okay? Yeah, 0 is an important number for this. But if x equals 0, there's no problem to evaluate this. F of 0 is just then going to be, x is going to be 0, so you're going to have 0 here. So f of 0 is 1 over 0 minus 5, which is 1 over negative 5, or negative 1/5. Okay, 1/5 you can locate on the x-axis. Subdivide the interval from 0 to 1 into 5 pieces, and it's the first one there. Okay, but anyhow, the point is that we do get a real number when we plug in x equals 0, so 0 is a member of the domain of F. And this is a set membership symbol. I'll write a little more clearly. Okay, sorry, I'm writing an epsilon, kind of an epsilon, but it looks like this. Kind of like a C, kind of an open C with a line there. Looks like kind of like an E, but and I suppose that you could finish this off as an E, couldn't you? Okay, but that's a set membership symbol. Everybody should be familiar with it, but not necessarily going to happen. Okay. Okay. Well. So the idea that 0 is not in the domain, no, but I think what you were thinking is you can't divide by 0, and here you're dividing by some number that depends on x. So the question is this thing you're dividing 1 by, you're dividing 1 by x minus 5, can x minus 5 be 0? Because if it can, the value of x is going to have to be excluded from the domain, since we can't divide by 0. Okay, so I say x minus 5 can't be 0, so we can make an equation out of this. Whatever the denominator is, we can set it equal to 0 and solve for x. Well, that's a very easy equation to solve for x. Add 5 to both sides, you get x equals 5. And of course, just by inspection, just look at it and say, well, if x is 5, that's going to be 0. Okay, so 5 is a member of the domain of F. I mean, yeah, I just read what I had written. 5 is not a member of the domain of F. I forgot to put the line through it. Okay? So for any x other than 0, x minus 5 isn't 0, and you can divide 1 by any non-zero number. I just say 1 over x minus 5 works fine as long as x minus 5 isn't 0. So the domain is the set. Open set from negative infinity to 5. Union the set from 5 to infinity. Now this union symbol, it's a standard set notation. If you've had the prerequisite courses, you've certainly seen it. But just to be sure, the union means we're in the set defined as this union with this if we're in here or in here. The other way we're not in the union is we're not in either of these sets, and the only number that's not in either of these sets is 5. Okay, 5 isn't included here because it's open. The interval is open. 5 isn't included here because the interval is open. So 5 isn't in this set. Every other number is. Okay, what's the range? Well, reason this out. 1 over x minus 5 can't be 0 because there's no number that you can divide into 1 to get 0. No matter how big the number is, you're going to get something when you divide into 1. It might be really tiny, but it's not going to be 0. Okay? There's no number you can divide into 1 to get 0. It's hard to say, I'm saying into 1, let's make that 1 a little fancier. Okay? So, if y equals 1 over x minus 5, well, we're asking, are there other values of y that we can't get? Well, we set y equal to 1 over x minus 5, and we solve this equation for x. Okay? Well, the solution's pretty simple. We multiply both sides by x minus 5, then divide both sides by y. We get x minus 5 equals 1 over y. No magical flipping things, although that does work. We just do the standard multiply, divide both sides by the same thing. As long as y isn't 0, we can do this. So x equals 5 plus 1 over y, because I add 5 to both sides. And this is okay. Okay. If y is any number except 0, we can get an x value. Meaning that we can get any y value other than 0. So the range is negative infinity, 0, union, 0, infinity. All the real numbers except 0. We can't get 0. That's a little bit of a tough point here to think about it. And you'll see, again, more explanation from the my open math. Now, there's one other situation where the domain is typically restricted. And there are other situations, but the ones you're going to encounter are pretty much these. Let f of x equals the square root of 2x minus 6. Now, your domain, 2x minus 6 can't be negative because you can't do a square root of a negative number. That's because there's no number that you can multiply by itself. It'll come out negative. Very straightforward reason. So anyhow, 2x minus 6 can't be negative. Square root of anything, whatever that anything is, that anything can't be negative. So in this case, 2x minus 6 can't be negative. Now if it can't be negative, that means it's got to be greater than or equal to 0. So we say 2x minus 6 is greater than or equal to 0. It's a simple linear inequality. Add 6 to both sides, we get 2x greater than or equal to 6. Divide both sides by 2, we get x greater than or equal to 3. You treat the inequality exactly as you treat an equality as far as solving it, except that if you happen to multiply or divide by a negative, you've got to reverse the inequality, just reminding you of that. Okay? So the domain is 3, infinity, and the range is, well, from this you can get any number from 0 to infinity, including 0. If x is 3, this is 0. Then as x goes through positive numbers greater than 3, this goes through all possible positive numbers. And I didn't write it down. I just said it in class because we're out of time. Range is 0, infinity.